Alright, so 54, I went ahead and I factored the numerator right here. And as you can see, the x plus 4 is going to cancel out. So the domain is going to be all x such that x cannot be negative 4. The wholes, well, when we canceled that factor, that became a whole, so it's at negative 4. And then to get the y coordinate, we plug it into the remaining factor right here. So we put negative 4 minus 4, so that's going to give you negative 8. It has no vertical asymptote because we canceled the factor and there's nothing in the denominator but 1, so none. This is a top-heavy rational function, so it's going to have a slant asymptote. And when you divide, you get x minus 4, because as you could see how we factored and canceled out the x plus 4. So it's going to be y equals x minus 4. The x-intercept, you look at the numerator, well, what's left, right? And you ask yourself what makes it 0, what makes this 0 if x is 4. So that's going to be 4, 0. And for the y-intercept, we cover up the x's. Again, either here cover up the x, or here we cover up the two x's, and you get negative 4. So it's going to be 0, negative 4. Alright, so number 55, we look at the denominator, and we see that x cannot be 7. So x such that x cannot be 7, because that would make the denominator 0. It has no wholes because none of the factors canceled in the numerator and denominator. Vertical asymptote, x equals 7. This one's a top-heavy rational function, so it's going to have a slant asymptote. And instead of long division, because I'm dividing by x minus 7, I'll use synthetic division. So I'll put the 7, 1 minus 4, 3. Bring down the 1, 7 times 1, 7, 7 minus 4, 3. And then the remainder doesn't really matter. All we care about is this part. Okay, so that's going to be y equals x plus 3. The x-intercept, we look at the numerator and ask ourselves what makes the numerator 0. Because if the numerator is 0, the whole function is 0. So it's going to be 3, 0, and 1, 0. For the y-intercept, we cover up the x's, and it's easier to cover them up when it's not factored. So up here, and up here. So you're left with this just negative 3 over 7. So 0, negative 3/7. And that's it. So the parent function for number 56 is this one right here. If y equals 1 over x, and it looks like this, like two branches, one in quadrant 1, one in quadrant 3. And so with the 4, the x minus 4 and the 3, those are the h and k parameters. So the x is going to be increased by 4, oops, and the y is going to be increased by 3, oops, plus. So the points, let's see, the points become 4 minus 1, 3, and then the y coordinate 3 minus 1, 2, and then for the second one 4 plus 1, 5, and 3 plus 1, 4. Okay, so remember when we translate to the right, the asymptotes go with it, and when we translate up, same thing, the asymptotes go with it, because the rational function has an asymptote right here on the y-axis and on the x-axis. So now we're going to graph it. Alright, so there you see the asymptotes, x equals 4 and y equals 3. The point 3, 2 goes here, and 5, 4 goes here. And that's all you need to draw the two curves, here and here, here and here. And there's the function. For 57, they're just asking for the domain. So we look at the denominator before we cancel anything, and in factored form, and identify the values that make the denominator 0. So we're going to say for the domain here, all x such that x cannot equal -3 or -5. Like that. For number 58, 1/5 to the negative x can be changed to x to the, x5 to the x, and it's the same thing. And that's what I did. So the reference points are 0, 1, and 1, 5, and there's no transformation. So I'm just going to go ahead and plot those. So 0, 1, and 1, 5. And then connect. And there you have it. So for number 59, exponential function. So the reference points are 0, 1, and 1b. B for the base. The base in this case is 2. So 0 plus 1, 1. Oh, and the h is positive 1 and the k is positive 2. So we have 1, 3 and 2, 4. So we're going to go ahead and plot the points 1, 3 and 2, 4. Okay, and because usually the horizontal asymptote is on the x-axis, but the k value plus 2 raises it up here 2 units. So then we connect the points. It goes like that. So for 60, another exponential, 0, 1, and 1 base is are the reference points. So the base is e. K is 0, so the horizontal asymptote stays at y equals 0 right here. And so now we're going to transform the points, 0 minus 4, -4, and then 3 times 1 is 3. And 1 minus 4 is -3. And then 3 times e, rounded to the nearest tenth, would be 8.1. Okay, so now we're going to plot. So it's going to be -4, 3, and then -3, 8.1, so about here. Okay, and so it just connect the points, and like that. Now at some point it is going to cross the y-axis, okay, but very, very high up. E to the 4th times 3. So whatever that is, e to the 4th times 3, that's where it's going to cross the y-axis. So I went ahead and plugged it into a calculator, and at 0, 163.8, it's going to cross the y-axis. So it's way off, you know. So that's why it shows like it's not right now. So don't think that this is an asymptote. It's not. It will cross it at this point. Okay, so for 61, the negative in front of the x, I can flip the e and make it 1 over e, but for this one I just decided to keep it like that, and did the transformation of negative x, so that's what you see here, and then the k is 6, so that means I can draw the horizontal asymptote right now at y equals 6, okay? And then the points would be negative, so it's 0. And then 1 plus 6 is 7. And then for this one, negative x is -1. And then e plus 6 is 8.7. Excuse me, I'm going to graph this. So 0, 7. And -1, 8.7. So about here. So it's going to come like this. So when you have an equation where the bases are equal, then you could set the exponents equal to each other. So this equals this. So x squared minus 4 is 3x. Move the 3x over. Factor if you can, and this one is factorable. And so x is 4 or -1. Okay, so here the bases are not equal, but we can make them equal. So always try to do that first. See if that's possible, because that gives you less work. If you can set the bases equal to each other, then it's less work than going to logs. Okay, So here we have 25 is 5 squared, so now I could set the exponents equal to each other. This equal to this. So x plus 1 is 2, so x is 1. So for this one, I know that 27 is 3 cubed, but I don't want 3 as my base, I want 1/3. So I'm going to use a negative exponent. So 1/3 to the 8x minus 1 equals 1/3 to the negative 3. Okay, and that gives me 27. So now I could set the exponents equal to each other and go from there. So 8x minus 1 is negative 3. I'm going to add the 1, so 8x equals negative 2. Then I'm going to divide by 8, and x is negative 1/4. For 65, you just have to convert from one form to another. So here they're in logarithmic form. They want you to convert it to exponential. So the base is 7, the exponent is 3, and it equals 343. So that's all you have to write. So 7 to the 3rd power is 343. In part B, the base, because it's natural log, the base is e. The exponent is 2.079, and it equals 8. And again, that's all you have to write. E to the 2.079 is 8. So on 66, we're going backwards. The base is 2, the exponent is negative 2, and that equals 1/4. So we're going to write log base 2 of 1/4 equals negative 2. Remember, on the other side of the log is always the exponent. For B, the base is e, the exponent is 1/2. So we're going to say natural log of 1.649 equals 1/2, equals the exponent. Alright, so just like with exponentials, if the bases were equal, we can set the exponents equal to each other. With logarithmic equations, if the bases are equal, we could set these numbers here equal to each other. Okay? In a sense, it's like dropping the logs. So we set 8x plus 8 equals 4. So subtract the 8 from both sides. 8x equals negative 4. And then x is negative 1/2 because it's a negative 4 over 8. Negative 1/2. And you go back to the original and you see, you have to make sure that the overall number here, after you plug in the negative 1/2, isn't a negative number or a 0. So negative 1/2 right here would give you negative 4. 8 minus 4 is 4, so that's okay, that works. Okay, so that's the answer. Okay, so we're going to graph the logarithmic function. The reference points are 1, 0, and base 1. Base in this case is e, and then the h value is positive 2, and the a value is 4. So that's why it's x plus 2 and 4y. So those become 3, 4 times 0 is 0, and then e 2.7, so that's 4.7, and then 4 times 1 is 4. Now remember, logarithmic functions have vertical asymptotes at x equals h, so right now with h being positive 2, the vertical asymptote is also at positive 2, at x equals positive 2. So we're going to go ahead and graph it. So there's a setup right there, the vertical asymptote's already there. So 3, 0, and 4.74, about here. And then just connect the points. So for A, 3 to what power gives you 81? So that would be 4. 3 to the 4th power gives you 81, so the answer here is 4. For B, if this base here is equal to the base on this log, then remember there's a property, so it just equals x squared. 8 to what power gives you 1? That would be 0, 8 to the 0 power. And then again here, like letter B, for D, if this base equals this base for this log, then the answer is just what you get here next to